Well, good afternoon, everyone. Welcome to the second Pandemic and Disaster Preparedness Center webinar in the context of the PDPC PhD education program. My name is Linda Jansen and I will host the webinar today. The topic of this webinar is climate change and water-related disasters. I'm not sure whether it goes well with the recording because I don't see myself anymore, but I see Ted. Is that right?
Well, it's being recorded, and I can see you. So
okay. Well, I'm sorry. We originally had two speakers today. Unfortunately, one of them had a personal issue only half an hour ago, so we only have one speaker today. But before I introduce him, I will share with you some practical matters. The webinar today takes 1 hour. Our speaker will take about 20-25 minutes, and after that we will have there will be 25 minutes or more time for you to ask your questions. We won't use the chat functionality for that, but we ask you to raise your hand. And so if you get the turn, you can ask your question, and we ask you to turn your video on. But as you have seen, this meeting is also being recorded. So if you have a problem with being on the recording, please keep yourself unshown. Our speaker of today is Hans de Mol. He is an assistant professor at Free University Amsterdam, and he studies there natural risk management and adaptation to climate change. His work does link to the work that's also being done by the Dutch Delta program, and he was involved in the fact-finding mission immediately after the 2021 floodings in Limburg. I think we can just get started. Hans will take part of the climate scenarios part in his presentation that was to be due by the other speaker, but I'm confident that he can do that as well. Hans, the floor is yours.
All right, Linda, many thanks and welcome everybody. Good to be here. As mentioned by Linda, I originally had 15 minutes, or I was one speaker out of two. But now I have some more time, which is good because I think I had too much content anyway. But I also spent a few minutes just before to include something more about climate change itself here as well. A little bit about my background. As Linda mentioned, I work at the Institute for Environmental Studies, specifically in the Water and Climate Risk Group. But my background, my studies is in paleoclimatology, so the climate of the past, the climate of the geological past. So from that perspective, I can also say something about climate change itself and those processes. So I just put one slide in, but if you have questions about climate change, how the climate system works, then by all means, ask me, because I'm also sometimes involved in some threads on Twitter about, with some, what do you call them, skeptics about climate change, with all kinds of arguments. So I've seen a lot of the discussions going on in that arena. All right, so let's start off then. So first off, a short bit about climate change. When we talk about climate change, we talk about the greenhouse gas effect and greenhouse gases. And for that, it's good to know, let's say, a little bit of the basics. I won't go completely into the basics because I'm not a physicist nor a meteorologist. But if the Earth basically gets heat from the sun, already long ago, they calculated that without any greenhouse gases, just purely the sun and the Earth and the distance between them, the temperature on Earth would be about minus 15 degrees Celsius on average. That is not the case. It is actually plus 15 degrees Celsius, more or less. And that is the result of those greenhouse gases. So those greenhouse gases in the atmosphere The two most important ones I would like to mention are hydrogen, just water vapor, which actually has, I think, the largest overall effect, but that cycles very quickly through the atmosphere. And then of the more permanent greenhouse gases, CO2 is one of the big ones. Resulting in us being able to live on this planet, because a planet of -15 is just a ball of ice, and chances are there would have been no life on such a planet. It's also important to realize that in the geological past, I mentioned I was a paleoclimatologist. CO2 was often part of what we call climate feedback mechanisms. What I mean with that is that the climate system is full of feedbacks. That means if something changes and it is a positive feedback, then it reinforces that change. So example I often give is the albedo feedback. So the North Pole is, a lot of sea ice, which is white, and that, the color white reflects the radiation from the sun back into the atmosphere. And water, if you look from above, from a plane, it's pretty dark. So that absorbs the light of the atmosphere, of the sun, the incoming radiation. So that's why it's also colder, on the poles. There's various reasons, but also that there's more solar radiation being reflected back like a mirror. But when it gets warmer, then you will see that sea ice starts to melt, which means that the white part gets smaller and smaller, which means that there's less and less incoming solar radiation being reflected back, which makes it warmer and warmer, which makes the melting even further, even faster. So that is a positive feedback mechanism. It gets a bit warmer, and then the ice gets a bit less, and as a result, we've got a bit more, solar energy coming in, or reaching a planet not being reflected, and it gets a bit more warmer, more, and even more ice melts. That's what we call a feedback mechanism. And CO2 has also been part of the feedback mechanism, and you see this nice graph of the ice ages, where at the top you're in the warm periods, on the bottom you're in the cold periods, and you can very clearly see that CO2 is alongside temperature going up and down. But this is actually triggered by very small changes in incoming radiation of the sun and our orbit around the sun, which is then being amplified by all kinds of feedback mechanisms. And in some of those mechanisms, CO2 is being released because warmer water actually can hold less CO2. So then CO2 goes into the atmosphere. So as the ocean warms up, there's even a bit more CO2 going into the atmosphere. And that, is also a sort of reinforcing mechanism. So that's how CO2 has been a part of climate change in the past, mainly as a feedback mechanism. But it still has a greenhouse gas effect, right? And we now put CO2 into the atmosphere ourselves, not part of a feedback mechanism, we do it by ourselves. And it has, of course, the same effect of, increasing warming a bit further. Here you see a very, famous graph from Hawaii, where they measure CO2 in the atmosphere. And you can see the red line that is going slightly up and down, up and down, up and down. And that's actually the natural, carbon cycle, fast carbon cycle, where over the seasons, in summer, CO2 is actually net extracted from the atmosphere. When all the plants grow, they actually extract CO2 to grow, with all the leaves and the grass and you name it. And then in winter, it decomposes, the leaves fall, and the CO2 goes back into the atmosphere, and that goes up and down. And that's huge amounts of carbon, which go in and out of the atmosphere. But we just add, a little bit on top of that with our fossil emissions, and that's about 4% a year. And you will sometimes see on Twitter that people say, the human contribution is only 4%. I mean, that's true, but it's 4% every year, and that adds up over time. And that's what you see in this graph, which is, going upwards over time. So already, naturally it would be about 300 an hour, at 425 or something like that. So that's not 4%, that's more like a 40-50% increase due to human action. Now, one other thing to think about when we think about the greenhouse gas effect is that it's sometimes being talked about as a bit of a blanket around the Earth, and it's a way of explaining it, but it's not exactly correct. A better way to think about it is that you need to think about the balance of the energy coming in from the sun towards Earth and from the Earth going out into space again. And what's happening at the moment is that the more, CO2 or other greenhouse gases that are in the atmosphere, the more outgoing radiation just gets ping-ponged into the atmosphere, basically. And if you add some more, it gets ping-ponged even longer, which means that there's less going out. And at the moment we have an imbalance. There's actually more solar radiation coming in than that there is going out. And what happens if there's more heat coming in than going out? We warm up, and that's basically what we see. And we also measure that. For instance, the high, very upper atmosphere, we see that's actually cooling there because the heat is being trapped more in the lower middle atmosphere. And that's that's actually measured with satellites very clearly, and also what we would expect given what the meteorologists know about the physics of the atmosphere. The reason I say it is that sometimes people, when they think about the blanket, they say, right, the blanket is already so thick, there's not more more heat that can be trapped, but it's really about what goes in and out, not only what is in and goes out, because that's a blanket, right? If you're underneath a blanket, it's your warmth which stays in, but there's no incoming warmth from the other side of the blanket. That's why the analogy is not completely correct. Lastly, there's many sinks in the Earth system. So the CO2 which we pump in the atmosphere doesn't all stay in the atmosphere. As mentioned, with the red wiggle, there's a lot of it going in and out into the biosphere, into plants and trees and soils, and it's also being stored there. There's also a huge amount being stored in the oceans. Think about phytoplankton, which is growing. It takes up the CO2, and then it dies and goes to the bottom of the ocean to remain there for a relatively long time. As in geologically long time, for us a huge amount of time. But I think about 40 or 50% of the CO2 which we put in, net stays into the atmosphere, and the other parts, the other half more or less, goes into the biosphere and into the oceans. So it doesn't all stay in the atmosphere, but I mean, the more we put in there, half of it will probably stay up there. Good. That's just a couple of things I wanted to mention about climate change and why whenever we add greenhouse gases, it will lead to a larger imbalance, and as a result, it will lead to a warming of our planet, because that's how greenhouse gases work. If you have any questions, write them down, and later on, please go to discussion. Or if you heard a very interesting argument from online from somebody who thinks he's a climatologist, please let me know, because there's often very funny misconceptions behind it, so to speak. Now, let's go towards specifically the water cycle, because my background is on water and water-related risks. And when we think about climate change and the warming of the planet, very often there's talk about floods and droughts, and sometimes I get questions, yeah, but how is it that we can have both more floods and more droughts? I mean, do we get less or more water? I mean, make up your mind, right? What is the case here? And basically, it can be both, because what's happening is that the water cycle, you see an image of the water cycle on the top right, is basically what we call accelerating. That warming leads to an acceleration of the hydrological cycle. You can see that a bit in the bottom right, where you see a graph which is going down over time a bit, and that's the residence time of water in the soil, if I'm correct, which basically means how long water stays in the soil. And you can see that over time, that's actually reducing, so it stays less long in the time, and that's what we mean with this acceleration. The processes basically go faster a bit. So it doesn't mean it gets wetter or drier with climate change. Basically, it gets a bit more variable because the processes speed up a bit. Now, what type of processes am I talking about? I'm talking, for instance, about evaporation and evapotranspiration, which is, where temperature is one of the driving factors. And theoretically, you should have, per degree warming, about 2% more evaporation going on. So that goes faster in higher temperatures. And you can imagine that if evaporation goes up, your soil dries out more quickly, and you have sooner or more intense droughts to obviously, temperature is not the only factor. Wind and moisture availability, they also all play a role, but it does play a role for sure, the evaporation. And what we actually see in our measurements in the Netherlands is even a bigger effect of than 2 degrees in the past. And we have had about a degree of warming up to now, right? But I think we've seen about a 12% increase even in evapotranspiration. But that probably has to do with moisture availability and wind and things like that as well. So we see that evaporation is going faster, basically, which affects droughts. And then when we talk about precipitation, there is another theoretical rule, so to speak, and that's the water holding capacity of the air, and that's the Clausius-Clapeyron ratio, which states that for every degree of warming of the atmosphere, that's, let's say, a package of atmosphere, let's think about a liter or a cubic meter of atmosphere, can hold 7% more water. So if you have a package of air which is 1 degree warmer, it can hold more water in there as water vapor. That also means that if that package of air is raining out, because it gets transported up and it cools, there's actually more water there to rain down, which can just lead to more extreme rainfall. So when it rains, there's more water which is coming down. And again, there are some other factors influencing it. The distance to the sea, actually cities have an effect as well. But this Clausius-Clapeyron rule is something we also observe, and we see an even slightly bigger effect in the Netherlands than the 7%, maybe even 9%. But that explains why we can have more extreme rainfall in a warmer atmosphere, in a warmer climate. So you see that both floods and droughts can increase at the same time, basically, due to a warmer atmosphere, because the processes involved go faster and there's more water which can be held in the atmosphere. Now, what does that mean that to the Netherlands and to floods and droughts in the Netherlands? First slide I always show, which I like, especially if there's non-Dutch people around, is this, a bit about background of the Netherlands. Very shortly, they sometimes say that God created the earth and the Dutch created the Netherlands. And that's actually up to a very big degree correct, because we think about the Netherlands also as, you know, a land below sea level, but that's also due to mankind. So the Netherlands didn't used to be naturally below sea level. Naturally, it was about, you know, the west of the Netherlands I'm now talking about. So the area of, you know, Alkmaar, Amsterdam, The Hague, Rotterdam. It was about, you know, +1 meter, maybe +2 meters above sea level. It was a peat area. But when we wanted to grow more crops, we started to drain the peat, because you don't grow crops in a swamp. So we drained those swamps a bit. And as a result, it oxidized and the peat went to the atmosphere and we got subsidence as a result. And basically we drained and later pumped our way to, let's say, -4 meters sea level. So I used to live Uilenstede, which was -4 meters here in Amsterdam. So all those blue areas, had those polder areas, that's not the natural way. That's because, you know, we as the Dutch pumped ourselves below sea level. But we are now in a situation where a quarter of the Netherlands is below sea level, and about half of the country is being protected from floods by dikes and levees, and has to be protected that way. So water is a huge issue in the Netherlands. And as mentioned, floods and droughts, they may be affected by climate change, or they are affected by climate change. So let me run through a couple of, you know, events in the past to show you a bit what it means for the Netherlands. Starting with droughts, because very often when we talk about climate change in the Netherlands, we talk about flooding. But since 2018, droughts are back on the agenda, fortunately, as well. Because in 2018, but also 2019 and 2020 and 2022, we had very dry years. Here in the bottom, you see some figures related to 2018. On the right, you see the what we call neerslagtekort, the precipitation deficit. That's precipitation minus evapotranspiration. So that's you know, how much extra water we would have liked to break even. And you can see that the black line is 2018, which was almost record level in July. But you see that we had a huge shortage of precipitation in 2018. which you can also see on this very red map here of about 300 millimeters less precipitation than evapotranspiration. That means that we had a big deficit, which then needs to be supplemented, right? If you want to grow crops in such a year, that water needs to come from somewhere. And here on the left, you can see what it means in terms of euros. They looked at the 2018 drought, and you can see that big bar here, that's all agricultural damages, and of about 1 billion euros in that year, 1,000 million, so 1 billion euros. You can see that also shipping had a big hit, and you see some other sectors which had trouble, but compared to agriculture, it was much less damage, but still non-zero, of course. And then if we go to 2022, you can see here in the graph, you can see the discharge of the rivers, of the Rhine River, our main river, and the black line is 2022. And here it's a green dotted line. That was the lowest ever in 120 years of measurements. And you can see that the black line actually just goes below there at some point. So we had some record low water levels on the River Rhine. And that, of course, has a huge implication for shipping. An uncle of mine is a shipper on the Rhine for inland shipping. And he mentioned that they had to go down to, down to 1/3 of their capacity, or sometimes even not going at all, to ship their products, which of course has a lot of economic implications, not just for the shippers themselves, but for all the industries related to that, right? And what does it look like from space? You can see a nice figure of 2021, which was relatively wet, and then 2022, which was very dry. In August, both of them, and you can just see that the fields are so much more yellow and less green as a result of this of the drought in 2022. Now, what do we do during a drought? Of course, a lot of measures are being taken, especially when it comes to salinization. Salinization is a huge issue, especially in the west of the Netherlands. What I mean with that is that the water is too salty to use for agriculture, for instance, which, as shown, was one of the biggest impacted sectors. And that salinization can come, we call it internal or external. Internal, it comes from the groundwater up. We've got seepage of salty water, groundwater, coming up, especially in our deep polders. In the middle of our deep polders, that actually comes to the surface. Or salt which arrives into our system just at the mouth of the river, where you have the sea, which is salt, and the river, which is not salt, and somewhere they meet, right? And there's exchange there. You can imagine that if you've got very low water levels, then the seawater can go more inland and allow for more salinization. But also the internal one. If you've got less fresh water to push down the salty water coming up, you've got more and more salt water coming into your polder systems, where we actually want to plant crops and grow crops, which then becomes problematic, of course. So what did they do? They did a lot of things in 2018, 2022, redirecting fresh water, getting storing water whenever they can, and then resupplying it again through those red arrows here to supply the rest of the Netherlands. And on the coast, where we have the sluices for the ships, they try to work with air bubbles, as you can see here. Putting air bubbles in to make a screen to separate the salty seawater and the non-salty fresh water from the river, so that there's not too much salt water coming in with the ships through the sluices. So a lot of actions are taken, and actually a lot of water in the Netherlands is used for this, for combating salinization in the west of the Netherlands, particularly in dry years. Now, then there's also, of course, wet years. As mentioned, we had a lot of dry years in the past, but 2021 was an exception. 2023 also, by the way, was also very wet. But in 2021, we had the big floods in Limburg, also in Germany and in Belgium. Here you see, just some images of that. You can see here where the rain fell. So it was on the Haute-Vanje, north of Luxembourg in Belgium, where most of the precipitation fell. But also in the Netherlands, we had over, I think, 140 millimeters in 2 days, which is a huge amount. It's like a couple of months of rainfall in a day or two, which completely flooded, for instance, the Ruhr, which you can see here on the top, the Ruhr River, which goes to Roermond from Germany. But also, which I think many of you will know if you were around in the Netherlands at the time, the flooding in Valkenburg, which you can see here on the bottom. And the top is actually a picture of myself where I hope you can see it, but like halfway here, you can actually see, I was there a week later. You can see that the bricks underneath are still wet and above are dry. So that's basically the mark up until how high that water came. So if I would be standing there, it would be chest height for me, basically. So this supermarket, they had to completely throw everything out and get new supplies on because everything was was tainted. It had, of course, a huge impact, and we did some research there. I can, go into a lot of it, but there's one thing I want to point out, and that's the compensation after the flooding, which was, as I put it here, complicated. And this holds for insurance and compensation after a flood event in the Netherlands as a whole, that it's not very clear. There were like 3-4 different ways where people could get compensation. One went better than the other, and especially the governmental fund, which is this one, the CCA, 6 months after the flood, only 20% or something like that was paid out. So many people were still waiting on their compensation, which of course has a big impact on those people and their businesses or their lives in general. The how to combat it. With this, I want to illustrate a bit that an event like this flood event in Valkenburg, in the Netherlands, we would often say, all right, let's build a big dike and make sure this never happens again. But I did a quick calculation just to illustrate what that would mean and if that would be feasible or not. So here you have a map, a top view map. This is the elevation. So this is the valley of the Geul. Here on the left you have Valkenburg. Here on the right you have Schillig-Geul. And you can see the river Geul meandering a bit through this valley, and the brown part is the higher hills of the there in Limburg. And if we would, for instance, store a lot of water, the amount of water we would need to store is basically the water above the black line, because above the black line, that's just what the Geul can still transport, but everything above will start flooding. We would need about 5 to 6 million cubic meters of water. I mean, that's a big number, difficult to see how much that is. That's why I did this experiment, a quick calculation on the back of the envelope. If we would, create a dam here just before Valkenburg, just to make sure that Valkenburg doesn't get flooded again, that dam would have to be 7.5 meters high, which would create a reservoir which would go all the way up to Schillig-Geul, basically. So we would have to completely fill up the valley there. And you can imagine that people cycling in that area would not like to see a 7.5 meter high dam with water behind that there permanently. But that's what would be needed if you would want to capture all that water. Just to illustrate that, and this is a point I will get back to a bit more, there is no one measure which is going to fix everything, because this is probably not something people want to let happen. And even if you would try to spread this out with smaller reservoirs left and right, you would still need a huge amount of the landscape to be devoted to that. Now, I talked about droughts and floods, but of course, in the Netherlands, the big elephant in the room is sea level rise. So if you go down to the coast from the highlands of Limburg, and we talk about sea level rise, then you see in the top right the Zeespiegel Monitor, so the monitoring program of the Dutch government on sea level rise. Every 4 years, they have a new report. This is the latest from last year, or 2 years ago, I have to say. And you can see that sea level has been rising from, about -20 to +10. So, has been rising, 20, 30 centimeters since the early 1900s. And then the big discussion is basically here. And it's the question about, is sea level rise accelerating, yes or no? And because the dotted line here is about, I think, a 2 millimeter rise a year. But if you only look at the last, let's say, 30 years, you actually get to a more steeper rise. You get to a rise which is about 3.5 millimeters per year. And that's concerning, because if sea level rise is accelerating, it's going to affect a country as low-lying as the Netherlands quite a lot. There is discussion about it. 4 years earlier, they did not have this change in acceleration. So this is something very recent, but this is something where the water managers in the Netherlands are keeping a really close eye on whether this is, continuing and happening, or whether this is just a bit of, variability in the data. Because if this is the case, it's going to impact a lot of our decisions, which I'll illustrate a bit later as well. And then here we have the scenarios for the future. So this was the observed sea level. And there you see a big spread. The two scenarios from the KNMI, the latest KNMI scenarios which just came out, you should basically view them, the low one as, I would say, unrealistically low, and the high one in terms of emissions as unrealistically high. So the red line basically means we start to use more coal instead of less coal towards the future. And then we get into the red line in terms of emissions. And this yellow one means that I think we're even better than the Paris Agreement or about there. And if you ask me, I don't think we're going to get there either. We're already overshooting. So in terms of emissions, we're probably somewhere in between those two. But they nicely, you know, create a space of, you know, in between where the future possibly lies. But that's just for emissions. Because when it comes to sea level rise, you will see that this low scenario in 2100 is about 45 centimeters. The high one is about 80 centimeters sea level rise in total. Then there's two things which are important. A, sea level rise doesn't stop. Even if we stop with emissions, it will continue, you know, also after 2100. And also if we immediately stop emissions. But also these more gray ones, which are going up very fast and high. And those are worst case scenarios, which we are looking out for in the Netherlands, whether that is actually happening or not. And those have everything to do with Antarctica. I won't go exactly into the details, but scientists are concerned that the West Antarctic ice sheet, you can see that in the picture here, may become unstable and basically, you know, slide into the ocean and degrade, which has everything to do with that ice sheet is actually not completely on land, but is partly in the sea. And there are some mechanisms there which may actually be self-reinforcing, as I was talking about earlier, right? Those positive feedback mechanisms, which may mean that it would go quicker and quicker. I'm not completely sure if it's the case yet. Some people are concerned. Some people say we can't conclude anything about it yet. But it's something to look out for as the Dutch government, because it will affect us quite a bunch. Now, what would be
Hans, sorry, can you work towards finishing your presentation so that we have room for questions?
I was afraid it would go way too long. All right, let me go. Thanks for this, Linda. So what does that mean? Sea level rise means a lot for the Netherlands. It means for flood and drought risk, it's going to be impacting. Also, the time we have to actually take measures. The faster it goes, the less time we have per half meter, so to say, to improve our levees or something like that. Think about the Delta works that took decades to build, but you would have less and less time if it goes faster and faster. And of course, the salinization I was just talking about, right, will even be more impacted. And then there have been also in the news lately, all kinds of statements about, research that the Netherlands, we can handle 3 meters of sea level rise. And there's these, these very nice views of the future about protecting our coast or accommodating. But I would argue that technically this is possible, and I'm actually quite confident that this is technically possible. But building high dikes is just one piece of the puzzle, because we will have, with a higher sea level, also more seepage, and already we use a lot of electricity capacity to get all the water out, which already led to discussions. Salinization, as mentioned, will only get worse and worse with higher sea levels, and it already is a huge problem. And a lot of our water is already used for that. You can see here about 45% of all our fresh water, and also compound events already happening. But if you want to know more about that, ask a question about it. So how to deal with this? If we talk about risk, we talk about a combination of hazard and exposure and vulnerability, right? The probability and the impact combined. And I like this disaster management cycle always a lot. And in the Netherlands, we also have multi-layer safety, which is like the Dutch variant, but that only has the prevention, the mitigation, and the response parts, not as much the recovery in there, but it's about the same thing. So this has already been 15 years ago. It has been proposed to use this. But if we look at how it is used, then we see that, well, we do work risk-based, as in probability times consequence. It has a very singular focus on the prevention. The Algemene Rekenkamer, who advises the government with the 25 projects, the layer 3, so the crisis management, was only explored in 2 projects and not part of the final plan. And for layer 2, so that's reduction of damages, it was explored in 7 projects, but then dropped because because of other considerations. And in the end, everything was basically about prevention again, which is important. But I do feel, and also Algemene Rekenkamer, that there are possibilities for those for other types of measures, but we lack a knowledge of the costs and benefits and responsibilities and the financing of those types of measures, which leads to the final conclusion, usually being layer 1 prevention in the Netherlands. So to conclude, climate change impacts hydrology, and in a country as the Netherlands, we need to deal with that. This means anticipating both too much water and too little water, as I explained. There are some limits to adaptation when we look at the singular focus. Think about Valkenburg. Just building a big dam is not going to work. We need a suite of solutions, of measures to work here, and very much also across hazards. So both floods and droughts, too much and too few water is important. And we can, maybe solve floods with 3-meter levees, but we won't solve our freshwater problems there. So I would like to advocate to use this, the whole of the disaster management cycle to reduce risk. And I think there are options in some of those other components in the Netherlands to improve as well. Think also about the insurance, which is currently complicated, which would be the recovery part, which doesn't have a lot of attention at the moment. All right. Hopefully not too long, Linda, but thanks a lot for your attention, and looking forward to the discussion.
Well, thank you very much, Hans. I'm sure there will be a lot of questions. I don't see any hands raised at this moment. I see some clapping hands. But as there are no questions yet, maybe I can ask you whether you can say something more about measures, concrete measures you are proposing, to deal with this upcoming sea levels. What do you think will be the most effective measures, Hans?
Would be the most effective measures? I mean, as mentioned, there's not going to be a silver bullet, right? Maybe I do go back to sharing screen, by the way. That makes talking sometimes easier. I think if we look at the disaster management cycle, then let's go backwards basically. So recovery at the moment, as I mentioned, it's complicated. That means that not all flood risk is actually covered by your insurance. You are covered when it is from rainwater or local water, but it's not covered when it's from water from the big rivers or the sea, from your insurer, which means that people in Valkenburg were covered by their insurer, and people along the Meuse were not covered by their insurer. And if you get to the confluence and you have water, then it actually determines where that water came from, determines whether you are covered by, you get compensation, yes or no. And that, I mean, you just get flooded, and as a if you live there, you don't care where the water came from, right? So that's really something which I think needs to be cleared up. And to be fair, there are currently ongoing discussions about a more national approach on that. If we go to the response, then in the Netherlands, it's about the crisis matter, the emergency management. It's the what do you call I need to think of the best word. Doesn't matter. But how that's organized in the Netherlands. That's together with the fire department and the police department. We don't have a crisis management department in the Netherlands. In all the other countries we do, but in the Netherlands we don't. Or emergency management. And also in projects of, for instance, dike recovery, they are not involved at all because they have very little capacity. So I believe that we really need to increase our capacity of our response. In 2021, it went really good. There were no casualties in the Netherlands, and everybody involved did a great job, if you ask me. But it can be, I think, more better ingrained in everything. With preparation in the Geul, we don't really have a good forecasting system. So for the Meuse, we do have a forecasting system, but for rivers like the Geul, because it's not the Rijkswaterstaat, but the water board, where the Meuse is Rijkswaterstaat. The Rijkswaterstaat has a good forecasting system, but in those other tributaries, we do not. So I believe there a lot can be gained. Mitigation is damage reduction. So there I think that especially we call them outside the embankments, so next to the river. There's also some cities in Kampen and Dordrecht where people live not protected by dikes. And I think there's a lot of ways to elevate your home, flood-proof your home, which is very common outside the Netherlands, but not so common in the Netherlands. I think more attention can be paid there. And prevention, I mean, we're king there, so I don't see, more things which can be gained there. The engineers we have in the Netherlands, from Delft, from Eindhoven, they're amazing. And there's a lot of innovation there. But many of the resources are now focused on that innovation, where I would like to see it broaden out to those other things I mentioned.
Okay, thank you, Hans. You addressed all the 5 areas. I have some new questions for you. Maarten.
Yes, thank you. For my own research, I'm looking at the weather effects of wetlands. And I wondered what your view is on wetlands and how realistic it is that those wetlands will be there, actually.
Are you talking about wetlands in the Netherlands or?
Yeah, indeed, especially in the Netherlands. Yeah.
Yeah, and then with respect to flooding or droughts?
Yeah, both. So they say that they can capture rainfall when there's too much, and that they can provide water when there is a drought.
Yeah, I think the storing of water is going to be very important in the Netherlands, because already in, let's say, semi-dry years, I mean, there are, scrambling to get water everywhere. And I think wetlands then come into play in the multifunctionality, so to speak. So if we want more areas to store water, and we want to do something useful with those areas, outside their storage, I can definitely see their wetlands playing a role there. I think when it comes to preventing flooding, I'm a bit more critical. Also in terms of, overall, nature-based solutions. I think they can be an important addition to the suite. But the amount of rainfall, for instance, in Limburg in 2021, 140 millimeters, there's, just the extra infiltration in the wetland is not going to cut it. That's just
Too much.
Huge amount of water.
Yeah.
So
and do you know about any plans to create such wetlands? Because it's really on the assumption in my front runner, but I'm not sure about that actually.
So what I would like to see is more almost field experiments on these types of things. Because I see very often that it's being included in plans, and then there's this, let's say, process theoretical notion of how it can help, but how big that effect actually will be, I actually think needs some more empirical work.
Yeah. Okay, good to know. Thank you.
Cheers, thanks.
Thank you, Hans. There's a second hand. Ted, you want to ask a question?
Hey, Hans. Thanks for your talk, by the way. So what about the surrounding countries? So the surrounding areas, are they benefiting from our disaster preparedness strategy as well? Like Belgium, Germany?
So there's many layers to this, Ted. Are they benefiting from our disaster preparedness? I mean, not our actions per se, but the Netherlands is a, let's say, exporter of knowledge on those types of things. So also, when there's high water in Germany, there's, pumping capacity from the Netherlands, which goes to Germany to help there. And in Germany, there were, I think, about 180 fatalities, just a huge amount in 2021. And that had everything to do with their response, and the communication there, which didn't go well. I'm not saying that's the reason we didn't have fatalities here, because it was not as extreme in the Netherlands than it was in Germany. But there's definitely, knowledge which can be transferred in and out. In Belgium, Germany, they will not benefit of our higher dikes. Actually, it's almost a bit the opposite. If they start to build higher dikes in Germany, we're in trouble. Because as soon as it floods in Germany, we will have less flooding. Because the water will be spread out, it will take a longer time, it will, peak less high as a result. So I always joke to my students that if there's a high water coming from the Rhine, and we know that like a week in advance, because then it's in the south of Germany, if we send in some bombers to bomb their dikes, that's the best way to prevent the Netherlands from flooding. It's also the best way to get World War III going, World War III going, but a big regional conflict. But if they keep the water in the river there and it flows very quickly downstream to the Netherlands, we actually have more to deal with than if it would flood there.
Thank you.
Hans, I don't see any other questions from the public, so I have another question for you. What do you think will be the biggest problem we are facing? Is that drought? Are those the heavy rains or the seepage? What can we best address?
I'm going to slightly alter your question, Linda. As in, where do I see the biggest challenge for the management? And I think that's really tying up in time and between. So it's really about what can we do now to make sure that we don't lock ourselves in the future. So if we blah blah blah, if I would go, go. I want to go here. If you look at the top, there's this protect, close, protect, open, advanced, accommodate. Those are really substantial changes to the way the Netherlands looks like, right? And we have not made a decision where we're going. But everything we do now, I mean, if we build homes somewhere, they're going to be there for 100 years. So making decisions now, still enabling us to move towards a certain future of the Netherlands and not, locking that or closing that door, I think is very important. So linking the short-term decisions we need to make now about we need more homes in the Netherlands. It's crystal clear. But linking that to those long-term changes, also about the distribution of water in the rivers of the Netherlands. There's also discussion about that. How much water goes through the Rhine, how much through the Waal. There are some big decisions to be made depending on how we want to see the far future of the Netherlands. And then also combining that, because this is from a flooding perspective, right? But how we want to, if you talk to municipalities or the water boards, flooding is only one of a whole scale of stuff they need to work with. They also need to accommodate the housing. They need to think about the salinization, and they need to reinforce the levees. So at the local level, all those different issues come together. And we have nature, and we have cultural history. That everything comes together at the local level, and that's where implementation takes place. And linking that local level with all those, different challenges to a long-term vision of where to go, which is not settled yet. That really is the biggest challenge, I think. And then we get into from Marjolein Haasnoot, the adaptation pathway, so to speak. So when do we keep open where we can still go with a certain no regret decision at this time, and which decision will lock us into a specific path, and maybe if the future pans out differently, then we make the wrong decision. So
the biggest challenge is actually the governance,
the integration,
how to make decisions, and there was recently an article, I think, in the NRC, and they also said, well, because the decisions that need to be taken are very huge, actually, it's also a democratic process. Which decision will we take? But that's, of course, very difficult because people don't actually know. Mm-hmm. Do you think it should be a democratic process, or do you think the experts should decide on it?
I mean, what I see happening is that it's such a big decision that no government wants to take it. I mean, we've seen it with if we go to the nitrogen crisis at the moment. Back in the days, it was called Mestoverschot, the manure crisis. When I was a kid, even before I was born, there are newspaper articles about this. But the impact of such a decision was, so profound for so many people, farmers in this case, that this was, delayed for decade on decade on decade, and now we're 40 years later, and now, or a few years ago, there was a government who did want to take that decision, and then, we've got all the societal upheaval we're in now. So and this would be a similarly big decision. So the way I see it is that's going to be not expert driven, but expert guided, so to speak. What can we do now, step by step, towards the future? Should you make it a democratic process and get a referendum out, on those 4 options? I mean, there's so many degrees of freedom within each of those options that it's not as binary a decision or binary. It's not A, B, C, D, but there's a huge amount of variance within each of those as well, which can make all the difference for. I'm a bit afraid it's too complicated for a direct democratic decision. Doesn't mean that we need an autocrat to make a decision, but hopefully that answers it a bit.
A big challenge. Still there are no other questions, so I continue the conversation, I think. We are also looking in the Pandemic and Disaster Preparedness Center, what happened during the pandemic and how the messages were gotten out and how to reach the public to start doing what is best for the context and for society. Right now, the message that gets out is, well, we in the Netherlands, as you just said, we can deal with 3-meter sea level rise. Is that the message we should send? Or should we be more specific in this message? We can do it, but it will really change our landscape. And do you ever think about these communication issues in relation to this topic?
I'm in essence relatively optimistic, also about the future of the Netherlands. I mean, the challenges are big, but I think also that when it's really necessary, things can also change very quickly. And the amount of knowledge we have in the Netherlands and the amount of proactive anticipation we have in the Netherlands is relatively unique. If we look a bit back to what we did in the Netherlands, there was in 1960, there was a big flood in north of Amsterdam, and then we started building the Afsluitdijk. In 1953, there was a big flood in Zeeland, and then we started building the Zuiderzeedijk, the big storm surge barriers there. But then in 2006, there was not a disaster, but that was when the Delta program was set up with the Second Delta Commission. And that was really anticipating perspective, not reactive on a disaster as it had been in the past. But you can see there's a much more, anticipatory approach to it at the moment. I mean, it can still be improved, obviously, but that does give me some confidence, along with the amount of knowledge we have in the Netherlands and the attention which is still there. The fund of the Delta program is 1 billion a year, which is outside the budget of the government. So that's it's not affected by direct political decisions. So that also safeguards that we have the resources to work with this, even though it may not be sufficient. But so those are all things which make me relatively positive. And for instance, this 3-meter that the Netherlands can handle 3-meter sea level rise. I think from a scientific point of view, it's a too simple conclusion, as I was mentioning in my talk, right? But I completely understand why that message is being sent out into the world. Because as the government of the Netherlands, we also need to make sure that the Netherlands is still attractive for economic investments, and that people still can enjoy living here and not in a sense of fear. So I also think it's a message not a scientist should give, but from the the politicians such message, I completely understand, and I also don't want to then write a big reply that it's not correct what they're saying, because that would undermine that message, right? So it depends also on who sends the message.
Okay, thank you. There's a question by Jeanette and Bart. I don't know who is going to pose it. Bart.
Yeah. Thank you very much, Hans. I think a very interesting webinar. I was wondering, because you showed us a lot about, I think, the vulnerabilities of the Netherlands as a country, or the regions, in case of floods and droughts and all the subjects that you mentioned. Are there also studies, or do we have insights on who are the more vulnerable groups in the Netherlands who will be hit hardest by droughts or by floods? Or do we have any insights in that, if this will develop and we as Netherlands are hit by these, who will be the groups within our society that will be needing extra care, or
Yes, there's definitely something known. It has many layers. When we talk about the droughts, for instance, I was mentioning that it's especially the farmers who are impacted a lot, but also that was not homogeneous over the Netherlands. There were areas where farmers were more hit than in other areas. If I'm correct, in Zeeland, there's actually not a lot of irrigation infrastructure around, also because they're farther away from fresh water, which means that they were actually hit more hard. And also the farmers on the Hoge Zandgrond, on the higher sandy soils, who are more dependent on rainwater, then the lack of rainwater will also affect them more. And also the type of crop, but I don't know which type exactly, actually affects whether you are impacted. It was actually for the fruit farmers, for the cherries and the apples and stuff. I think they actually had a slightly better harvest that year because of the high temperatures. And so it depends on what you're farming and where your farm is, what your vulnerability is. And a student of mine did a survey, and she also found that also the size of the farm actually depends on how well you can cope with it. The larger farms, they have more capacity to adapt than the smaller farms. So especially the smaller farms in areas which are more vulnerable geographically, those would be in danger. If you talk about flooding, there's also a couple of layers. We saw that it was the ones who fell between the ship and the quay, as we say in Dutch, tussen wal en schip, who fell in between the cracks when it comes to compensation, were actually the very big organizations, like Child Care Hospital, who had their insurance not with a Dutch insurer, but with an international insurer. And the Dutch insurers, they actually compensated the flood along the Geul, but the international ones did not, because it was not in their policy actually. And then the government actually has the rule that only uninsurable, so if you cannot insure it at all, then the government will step in for compensation. But if they would have had a Dutch insurance, they could have been insured. So according to the strict letter of the rule, they would not, could not get compensation from the Dutch government. I mean, there was all kinds of, I don't know how it ended up, but that's where actually the really bad examples from compensation were. And then if we go towards Rotterdam, where there's people living outside the embankments, so we're not protected at all by a levee, but they live directly on the river. Some years ago, I think now it's different, but when I did my PhD myself, they did a survey, and half of them did not know that they were not protected by levee. And if you look at the socioeconomic level of the neighborhoods there, it's not the wealthy neighborhoods. It's the lower home prices neighborhoods, so to speak. So yeah, it always depends a bit on the combination, I think, of the area and the recipient itself. But yeah, there are some things known left and right about it.
Well, thank you, Bart, for the question and Hans for the answer. Actually, it's 2:00 right now, so I really would like to thank you for giving your lecture, sharing your knowledge, and also for taking the place of the other lecturer so last minute. Thank you all for attending this webinar and hope to see you next time. Thank you.
Excellent. My pleasure. I hope you all learned something, even if it's just one or two things.